Hello everyone. And we are moving on now. Let me show you to a very important exercise. An important exercise we are going to be doing. Let me share my screen. Alright, guys, you need to have your textbooks open to exercise 11, mixed questions. Okay. And you've got a whole lot of mixed up questions which uses all the techniques that we've used so far. The most important part in integration is literally your first step, where you're able to identify what technique to use when. There's a summary on the left-hand side of the page. This is my little version of the key we're going to use. So what we're going to do is I'm going to give you, well, however long you want. Okay, I want you to write down key phrases next to each question. Okay. Which is kind of going to be your triggers for how you're going to do the sum. I'm not saying you can go do half the right-hand column later by yourself, okay, and practice some of those. If you want, you can do the whole exercise. But the most important thing I want you to do now is an exercise where you're just identifying what you're going to do in that sum, what your technique is going to use. I want you to spend 5 to 10 minutes doing that. Okay, so the key that I'm going to use, okay, I sent this to you as well, is, well, the first thing we look out for is just to simplify out, to times out or divide out and use your basic rules, okay? The next thing we look for, so I want you to write, you can either write the code, number 1 and number 2. The one thing I do want you to write a bit of detail is if you're going to do a substitution, I want you to write down what you're going to let u be equal to. Okay, so say let u be equal to cos 7x or cos 2x or whatever it is that you're going to use. Okay, another code you could use is number 3. Okay, remember, if you've got something with cos squared theta in, to isolate cos squared theta, you're going to use this whole thing over here. To isolate sine squared theta, you're going to use the cos double angle formula over there. There's an integration for, you can integrate cosec squared and whatever it is, okay, the basic ones, okay, the integrals, but, so in other words, you've got to be able to, for tan and cot, you've got to use the fact that tan squared is equal to sec squared theta minus 1, okay, and that cot squared is equal to cosec squared theta minus 1, because there's an integral of cosec squared and there's an integral, okay, of sec squared. Right. Remember, you should have your formula sheet in front of you, which has, I've got it here, I should have it here. Here's the trig ones. Trig, which has all of these over here. So if you, on page 264, this is showing you that the integral of cosec squared is cot, and the integral of sec squared is tan. Okay, all right. And likewise, the integral of sec x tan x is sec x. Okay, so you've got to be comfortable going from right to left there. You'll need your information sheet with you as well. Okay, got to always have that with you. So look out for tan squared. Anytime you see a tan squared, you rewrite it as sec squared minus 1. Cot squared, you write it as cosec squared minus 1. If you see a cos squared theta, you've got to use this, isolate cos squared from the double angle formula. Likewise with sine squared. Your trig expansion formula, okay. So if you have sine of an angle, cos of a different, sine of a different angle, that's the technique you're going to use. They're all on your information sheet, okay. Look out for those as well, the product of trig functions. Okay, remember here the integral of 1 over ax plus b. It's equal to ln of ax plus b divided by a to compensate for the chain rule. Okay, ln of the absolute value, that should be of ax plus b divided by a. Look out for this integration over here, that if you have the integral of e to the f of x, it's equal to e to the f of x to compensate for the chain rule, divide by f dash of x plus c. Okay, if that's linear, use partial fractions, look out for that. And don't forget integration by parts. Okay, very often when it's x times something else and substitution's not going to work. So we've got techniques 1 to 8 there. Okay, you're going to try to use those. Okay, so I want you to just spend 10 minutes now, writing keywords, next to each thing. So I'll do 2 with you. the first two with you. So what technique would you use here? Well, here, well, basically you're going to use number one, you're going to simplify out. Yeah, so you can just put the code and basic rules. This is a really key skill that you start picking up now, what to use when. So that's what you're going to do. You're going to use that number one here. In question B, you're going to do a substitution. So it's 0.2. But when you're doing a substitution, I want you to write down for me what you're going to let u be equal to. Well, how can I use a substitution? Because if I differentiate x squared minus 2, I get 2x. So you're going to let u be equal to x squared minus 2. Okay? And remember, once you've done that, du dx will be equal to 2x. I don't want you to do the whole thing. I just want you to write that step over there for me, etc. So you got to get rid of the 4, etc. So you got the idea. Okay? But I just want you to say, okay, the first step, the key idea is what am I doing in question 2? I'm letting u be equal to x squared minus 2. Right, you don't have to write the rest of it. Don't even worry about that for now. But just check in your head if it would work. That's 2x, so it's fine, because we can get into x. Right, so I want you to spend 10 minutes, okay, doing the rest from C to N. Do all of them, okay, but not the sum. I want you to just write down what technique you're going to use in what circumstance. Okay, so press pause, okay, and go try that. It's a really important exercise. Right, welcome back. Now that you've tried them all, okay, so let's have a look. So in question C, okay, again, I'd let u be equal to 2x plus 1. I'm going to do a substitution. Number 2. Okay, let u be equal to 2x plus 1. Right? Okay. What you'd have to do, though, in this case, because du dx would just be a constant, is you're also going to have to substitute out. Always remember, guys, I would always first remove that constant. So I'd take out the 2. In this case, you're going to have to also isolate x from this statement, okay, because you've got to get rid of that x as well, which is not going to happen automatically when you differentiate. So you're going to have to isolate x and do 3 substitutions. You're going to have to get rid of the x on its own, getting x is equal to u minus 1 over 2. You're going to have to differentiate to get rid of that dx, and then you're going to have to replace 2x plus 1 with u. Everything has to be in terms of u, and then you're off. Okay, but the key idea is you're going to do that substitution, but don't forget, unlike in this case, where the x will become part of, in this case, the x will be part of the differentiate, the x dx part. Okay, it's not going to be. So you've got to do a separate substitution by isolating x. Okay? All right. In D, well, this is just a straightforward one. Okay, it will be sine 7x over 7. So it's just basic rule, basic, number 1. And you're going to, don't forget to compensate reverse or chain rule. So you're going to have to divide by 7. So it'll be sine 7x over 7. So that's your basic one. Okay. Cot squared. There's no integral of cot squared. Okay, but there is an integral of sec squared. Okay. So here, your key idea is you're going to have to use the fact that 1 plus cot squared is equal to cosec squared. So in other words, cot squared is equal to cosec squared minus 1. So in this case, the key idea is that cot squared 2x, okay, cot squared of an angle is equal to cosec squared of that same angle, in this case 2x. Cot squared of 2x is going to be equal to cosec squared 2x minus 1. So you're going to replace cot squared, okay, with that over there. Cot squared 2x is equal to cosec squared 2x minus 1, and then you're going to do your integration. Okay. Right. F. Well, the substitution is going to work here. We're going to let u be equal to 3 plus 2 sine x. Because then what will happen, okay, is that du dx will be equal to 2 cos x dx, and you can go from there. Right. Yeah, we're also going to do a substitution. And once again, whatever's got the power in it, that's what you're going to let be equal to u. So you're going to let u be equal to cos x, right? Okay, and then du dx would be equal to sine x. So du would be equal to sine x dx. Here, you're going to have to use the expansion formula for sine of an angle, cos of an angle. And if you look at the expansion formula, sorry, I should have an information sheet with me. Okay. Sine A, we've got sine of an angle, cos of a different angle, and sine of an angle, cos of a different angle is going to be a half cos A minus B. So you're going to change it to a half cos A minus B, so 5x minus 2x. Okay, a half cos one angle A minus B using this formula over here. Okay, sorry, sine and cos. Where's the sine and cos one? Oh, sorry, sine and cos. You're going to use a half sine of an angle, cos of a different angle is a half. Get forward for it. But let Nan in. I kicked her out for the warning. Get that. It's going to be, you're going to use this formula here. Okay. Sine A cos B is equal to half sine A plus B plus sine A minus B. Okay, so it's going to be a half sine A plus B, 5x plus 2x, okay, whatever it was, plus sine 5x minus 2x. Okay, so when you've got sine and cos of a different angle, don't forget those formulas. Okay, right, so that's that one over here. The trig expansion formula. Trig expansion formula is point number 6 that we usually there. Okay, right. Cos squared 3x. Well, you've always got to be careful of cos squared. You're going to have to use this thing over here. You're going to have to use the fact that cos 2 theta is equal to 2 cos squared theta minus 1. So in this case, cos squared, okay, your angle that you're working with though is going to be 3x. But that's your key idea that you've got to look out for. Okay, cos squared theta, cos 2 theta is equal to cos 2 times an angle is 2 cos squared of the angle minus 1. This one over here, a substitution is not going to help us. So you're going to have to take out the constant 3, and then you're going to use integration by parts. Okay, so you use parts, point number 8. Okay, and in that formula, you'll let f of x be equal to 3x, and you'll let g dashed of x be equal to sine 4x. Okay, then you're going to use the integration by parts formula. In this one over here, you're going to use this point over here that the integral of e to the f of x of a linear function is e to the f of x over f dashed of x. So you're going to be using point number, this one, sorry, over here, that expansion formula was point number 4. Okay. Here you're going to be using point number 6. You're going to use the fact that the integral of e to the f of x is e to the f of x over f dashed x plus c. Okay. Point number 6 you're using over there. Okay. This one over here, it's a linear function at the bottom, so you're going to use point number 5. Okay. Which is that the integral of 1 over ax plus b is equal to ln absolute value of ax plus b plus a constant. Okay. Okay, right. Then in question M, okay, well, it looks like a substitution is going to work. Take out your constants first. Okay, I would take out 2 from there, and then I'd let u be equal to, okay, you've taken out 2, so you're going to let u be equal to, sorry, it's chaos here. Let u be equal to 3x squared minus x to the 6, because you would have taken out that 2 first. Okay, and then du dx will be 6x minus 6x to the 5, okay, and you can work from there. Okay, so I just do a substitution. It's not such a simple one. Okay, but that's the one you're going to be doing. Sorry, point number 1 over there. Here, substitution is not going to work because you're going to get 2x minus 3. It's going to be a bit of a mess. Okay, and this one just, so I would here in this one you're going to have to use integration by parts. But it's not by parts, integration, sorry, use partial fractions. Okay, so you're going to have to use partial fractions in order to that one. Parts isn't going to help you. Okay, partial fractions is going to be your best bet over there. But really, that in integration in these kind of questions, that first step, being able to identify what to use when, is really critical. So it's up to you now how much you want to go do. Okay, you probably won't have time to do the whole exercise. It'd be really good if you could, but at the very least, I would say go do what side looks more efficient. Probably go do the right-hand side. Okay, but they're all pretty good. Okay. All right, guys. Okay, and then we've just got volume to go. Then we finished integration. Okay, it's a mission AP. I'm not going to lie. Okay, I'll then give you a practice test for integration, and then we're going to start some stats. All right, take care, everyone. Arrivederci.